Hello everyone and welcome to more discussion on groundwater exploration. This is part 15 and here we will be discussing about spontaneous or SP logging or spontaneous potential logging, and some more logging methods we will be also including in this discussion. As you recall that in previous discussion we have mainly discussed two types of logging. One is hydrogeological logging and another one is geophysical well logging, and especially we more focused on the resistivity logging. So, here we will be discussing, as just mentioned, that spontaneous potential or SP, in short very popularly known SP logging. So, SP log records the depth wise natural electric potential of points with respect to the fixed point on the surface. So, you have seen earlier that a point is chosen and then a spontaneous curve, spontaneous or SP curves are obtained, and they will give you the information about the different types of formation present in a well log. So, the potential and this spontaneous potential is because there itself on that point also. So, potential is caused, this spontaneous potential is caused due to electrochemical effects between the dissimilar layer, different layers, and electrokinetic effects produced by the movement of borehole fluid through the permeable beds. So, the important point here that the borehole, the fluid which is being injected, how it moves through permeable beds, and in a group of formations, because you would be getting different kind of formations in a log if it is quite deep, then the clay beds have approximately the same potential defined in SP curve by almost vertical straight line called the shale or clay base line. So, in that case, if you are encountering shale or clay, then you would get a vertical line or a vertical straight line in the curve, and that example we will just see. So, potential at the shale line is treated as 0, that becomes our reference, and reflection of the SP, that is spontaneous potential curve, to the right are treated as positive and to the left as negative. So, here this we are seeing potential curve versus resistivity curve, and we have also in between we are having our litholog information about the different formations which are present in a well. So, what we encounter when we encounter the shale, here the formation is quite thin. So, it is, though it is having its signatures, but not sufficient. So, this what it is said on the right are the treated as positive. So, here we will on the right side we treat as a positive deflections, and on the left we treat as a negative reflection. So, the potential baseline at when shale should be set at the same time and place as resistivity base. That means, while comparing this should match, and this is matching in this example, the resistivity baseline always set in the shale or clay. So, these are kind of I can call them as marker beds or reference beds, because their characteristics are well known, and therefore, these are being used in case of comparison between potential curve and resistivity curve or otherwise also. And wherever you are seeing, like in case of sand, if I take that example. So, here the potential curve are showing very less value or as negative values, and in case of resistivity curve they are showing high resistivity. So, if you see both, though these are schematic, but if you see the potential curve and resistivity curve, they are just mirror image. So, that might also confirm if something has gone wrong in one of these logging, then it will tell you that what has happened. And so, there should be almost a mirror kind of image is there. So, if a water in a permeable bed is more saline, now we are talking about the quality of water. So, when water is more saline, then drilling mud, the SP is generally more negative in the permeable bed, and it will move towards the left. Then the adjacent clays, Whereas if the formation water is less saline, then the mud, the SP becomes more positive and it would move towards right against the permeable bed. Extreme negative reflections may be joined to form a sand line, and this is what we are seeing, a sand where it is negative thing. So, this kind of interpretations of SP logging can be done. Now, sail line and the sand line will be parallel to the vertical axis if the salinity of borewell fluid and formation water are constant throughout the length of the borehole. Sometimes it is not possible that you are having this bore fluid and the salinity of bore fluid and the formation water having the constant characteristics throughout and the depth. It is not necessary. So, sometimes these things keep happening and may not be, you will be having interpretations of these as easy as shown here in schematics. Further, the SP and resistivities of drilling, which is shown here also, SP and resistivity curves are shown, and the formation water are related as follows under the certain conditions, and we have seen already. So, here we can have a relationship that SP spontaneous potential is minus K log 10 RMF upon RW. So, here SP is of course log deflection in MB, then K is a coefficient, then you are having RFW, that is resistivity of mud filtrate and ohm meter, and RW is the resistivity of formation water, again ohm meter. Now, the relation holds good if the mud resistivity is much higher than the formation water resistivity, and we are talking only in that case when mud is being used during the drilling. Many times in case of groundwater drilling, mud is not used, but in case of course oil drilling and others, definitely in many cases the mud is used, but depending on what kind of techniques one is being employed. So, in this the mud resistivity is much higher than the formation water resistivity, and it will hold good this relationship if in oil field brines NaCl is predominant salt in the formation of water and bore well fluid. So, in case of oil industry, this differentiation has to be also done. So, that is why, otherwise in case of water things would be little simpler. The formation is free from clay horizons and finally, the potential developed is entirely electrochemical. As said in the when we started this geophysical well logging discussion, I said that such kind of investigations for geophysical well logging are done only in those cases where we need a lot of water round the time for some industry or for some big colonies or for cities or irrigation purposes. There all kinds of informations are required to make sure that the whatever the estimations are there, it will provide that kind of water. But for domestic purposes or for small colonies and other things, many times such detailed analysis about geophysical well logging and other things, in fact the well logging itself will not be done. If it is done, just resistivity will be done and so on. But here we are talking all possible methods which can be employed in case of geophysical well logging of water or water well. Now, this in this spontaneous logging, in view of these limitations, we have put the conditions only when the relationship will hold. Those limitations, the water well practice, the equation is strictly applicable only when the formation and the water is brackish or salty, containing not less than 15,000 ppm of dissolved solids, because everywhere you are not getting fresh water. So, these things have to be also considered. The quality of water is another very important thing along with the quantity. Of course, quantity is equally important, but quality of water is also. If we are getting some kind of brackish water, salty water, brackish water may be because of meteoritic water. Sometimes in a deep aquifer conditions we may get a meteoritic water, and that may have a these dissolved solids to some extent. So, qualitative information can be obtained when the formation water is fresh, and basically we need for industries or for big supply, we need quality assessment of groundwater as well to large extent. So, interpretation can be improved if the chemical qualities of groundwater in the region is known. Beforehand, if it is known, fantastic. If it is not known, then it has to be analyzed. Then only we can proceed further. Now, other types of logging. So far we have seen in previous discussion resistivity logging, electric logging, the hydrogeological logging, and we have seen now SP logging. Now, other types of loggings are there, and some examples like gamma, neutron, caliper are also seen here. So, now we will include in our discussion these. So, other types of logging methods useful for very specific purposes. So, in all cases, all types of logging should not be done, not required to be done, and their common application in hydrogeological studies include radiation, acoustic, temperature, caliper, fluid resistivity and fluid velocity and tracer logging. So, first we will take say radiation logging, or that will create a gamma log which you are which is marked here with the red box. That in radiation logging, the difference in the intensity of natural gamma radiation, that is natural gamma logging is measured. And if I just compare, they see that radiation in case of natural gamma radiation in case of shale is higher, and similarly when we encounter another shale patch or shale layer, we get again higher, but when we get the porous sandstone with salt water, it is lower here in this part. So, this gamma, the natural gamma radiation, that is the natural gamma logging also is get affected by the lithology, and not only with the lithology, but also with the salinity of water. Like here it is written salt water. So, salt water will affect also. So, the radiation logs have a fundamental advantage over electric logs in that they may be made even in the cased or when you are having casing pipes filled and the fluid or even in the dry holes. So, almost in all kind of bore wells, this radiation logging or gamma logging can be done, natural gamma logging can be done, because the radiation even coming through even these pipes also. So, no issue about that, but most of the loggings are done before the casing is put if it is required, but in some case if it is later on it is required, even then it can be done. So, only if there is a submersible pump that has to be taken out, then you lower the instrument and record this natural gamma logging, or can create natural gamma logging, or can record the intensity of natural gamma radiation. These are also useful in identifying formation boundaries, and that is the purpose, basically that is the purpose of all kind of well logging, to find out the lithological boundary accurately, because lithological boundaries may not be accurately recorded when drilling is being done, because then when rock pieces are coming, sometimes they are having very fine sediment, mud, water, and when you wash it and put it, then the depth information may be mismatch or other thing. That is why all these logging methods are there. Now, in this radiation logging, appreciable differences in the range of natural gamma activities between clay bearing sediments like shales. Clay is also there, and you can see there is in gamma it is a peak, in case of shale again there is a peak, in case of shale again there is a peak. So, the natural gamma activity between clay bearing sediments and weathered igneous rocks and clay free rocks make the natural gamma logs useful for correlation of rocks in different bores. So, that will help us to better understand about the lithology. Lithology means we are developing better understanding about the availability of groundwater and also quality of groundwater through all these processes. So, gamma log or natural gamma logs can be interpreted in terms of bulk density and porosity of rocks as well. Now, here in this radiation logging, indirect measure of water content in the rocks is obtained from neutron logs. So, neutron log is the next one, our this one neutron log, and the log can be used to interpret position of the water table and porosity of rocks, and that is another important thing, that we would like to know that where water table is here. So, here see the neutron log, there is a sudden change in the CPS value. So, these are again confirmations of whatever we have so far obtained in case of resistivity log and gamma log. Through neutron log also confirmation there. Some other logging methods, that includes the temperature logs, also discussed earlier, that the temperature information in many cases is very important. Record the borehole temperatures which help in the applying temperature corrections to resistivity. For those also the temperature values are required, and their corrections are done about the permeability and other temperature dependent parameter, detection of position of cement seal in the wells and circulation of groundwater. So, here these two are shown of two different months about the temperature records, and the temperature is varying with depth. See, this is the casing bottom here, that is marked. So, the top part is showing lot of variations in between November month and June month, but the lower part below this casing bottom you do not see much variations as compared to that in the top part or top part of the bore well. And so, this is the depth which is shown here, this is the temperature is shown here. So, like 13 degree, as you go lower on the surface, the temperature in November month was like this, as you go lower you keep getting less temperature, but in case of June month there is not much variation in the temperature. So, temperature is important from industry's point of view, temperature of the water which is going to be available, and temperature information is also required for the corrections of resistivity, permeability and other related parameters. Now, other methods can also be of well logging methods can also be applied, that is acoustic velocity logs and also called the sonic logs or transient time logs, are a record of travel time of acoustic waves from one or more transmitters to receiver in the probe. So, depending on what kind of detailing information you are required, like here acoustic velocity is recorded and caliper, that means the diameter of the well is varying here. So, then whether, and of course, the litholog will always be there, lithology will always there. So, what we see here, a thin limestone layer of formation is found, that limestone, the thin limestone, and all of a sudden the acoustic velocity has increased. So, there is a complete peak, distinct peak can be identified. Similarly, there is andesite or anhydrite is there, again a peak is there. So, different kind of rocks formations in a well which will be encountered are showing different acoustic velocities. So, we start with say quartz or sandstone, high silica rich sandstone, then there is not much variation. But as soon as you encounter limestone, suddenly the acoustic velocity increases, and then again you come to the sandstone, it comes back here, and likewise. So, these can also be useful for certain things, like we know that acoustic energy travels through the fluid in a bore well and through the surrounding rocks at a velocity that is related to the matrix mineralogy and porosity of rocks. So, different rocks will have different mineralogy. So, therefore, the acoustic energy will behave differently, and if porosity is varying with say in the same rock, but porosity is varying, it will again have the different acoustic energy levels. Now, in sonic logs are used of course, for the identifying of the lithology. They are extensively used in petroleum industry, in water. Porosity is an important thing in both these industries. Sonic logging equipments are now installed in some of the water wells loggers also. So, there are multi-instrument loggers are also there. So, you lowered one load of data, for other logs are also available at the same time. Now, variations in the bore well diameter, as we have been saying, the caliper, is due to caving, and presence of fractures are recorded in caliper logs. So, caliper log at the diameter which changes with depth or having a major influence because of lithology, that is also recorded. That becomes very important from the maintenance or health point of view and casing point of view also, screening point of view also. So, like here if we see here that what we are seeing here, that it is the limestone and we are getting the caves here, and the caliper, that means the diameter of a well at this location has gone very wide, and a sort of cavity has been found, encountered, and that is what it is recorded here. Even in acoustic velocity, lot of variations are seen here because of this cave. Whereas in case of sandstone, which is here sandstone, and here you do not have those variations. And again, as soon as you get the shales here, these are the shales, I can write SH, then there are not much variations. But in case of limestone having caves, the caliper log is also showing a cavity inside, and your acoustic velocity is also changing quite significantly. So, these are again important informations about this. Now, because we have to think about the health of a well, so that well will last for very long time, there will not be much problem, not much sediments will come, and performance of the well overall, the pumping and other things, the quantity of water will remain constant and so on. So, corrosion, intrusion, incrustation, because incrustation also occurs especially when you are having a calcium rich terrain or a lot of limestone and other things. Parting of casing and other conditions of well assembly, which are very important about caliper logs are important for all these. And uncased holes can be viewed by lowering a portable CCTV. Nowadays, it is also being employed that if we encounter a cavity, we would like to see through a CCTV and record that one also. So, that appropriate measures at the time of development of the well log and what kind of well assembly should be installed can be assessed beforehand, before anything really happens. So, with this I end this discussion. Thank you very much.